So finally, let me conclude this discussion with the what question. Broadly, what is the what question? Well, let me first tell you what it is not, right? So it's not a program, right? So it's, we have already seen this. It's not like you are given an input and a program like a tax calculation, right? So the input is, you know, how much, what is my salary, how much did I spend, how much did I save, you know, not spend, how much, what is my salary and what is my savings, and then, you know, the tax is just a formula that I can apply to this input to get as output. It's a simple procedure. That's not what we call by learning. It's not memorization. It's not like, you know, in the weight versus height example, we memorize that if the height is this, the weight is this. If the height is this, the weight is this. We did not memorize that, right? So because if we memorize that, we are only memorizing the examples, right? So we cannot generalize well, right? So we have to hypothesize a more general way to connect input to output. So just memorizing is not learning, right? So memorizing is never the solution, right? So if you have memorized, it does not mean you have learned. You've just memorized a bunch of things, and computers are very good at memorizing. Now we want compute because they have huge computational power, much more than any human, and they can memorize huge amounts of things, more than what a human can. But humans learn, right? So our brain does not have so much capability to memorize, but it has a huge amount of capability to recognize patterns, form hypotheses, abstract things out, and learn. And that's what we want computers to do, right? So if you want computers to mimic humans and their capabilities, we don't want computers to just memorize. We want to go with them to go beyond just memorization. And it's not some magic, right? So we saw some simple ideas how to observe, hypothesize, you know, learn and generalize. Though, you know, a lot of interesting things, your chat GPTs and whatnots, Geminis and whatnot do a lot of interesting things these days. It's not really magic, right? So what is, what then, what is it, right? So if it is not procedural, if it is not memorization, if it's not magic, what is it? Well, it's not procedural, it's data driven. You are given the input and the output, and you are asked to come up with the mapping from the input to the output. The data decides what is the right line, the data decides what is the next number, right? So it's data driven. Well, if it is not memorization, what do we care about? We care about learning, and we care about learning because we want to generalize to unseen situations, right? So if you're out, if you're going to be tested in your exam on exactly the same questions that you are taught as examples in class, then somebody who memorizes will always score the best, right? So but that person may not necessarily learn, so that learn the concept, right? So if you have to do well on a test which asks you something conceptually, just memorizing the examples is not going to be enough. You should learn, you should know how, what is the real concept hidden in the examples. You have to understand that so that you can generalize and do well on your test, right? So it's same, exactly the same idea. The data is there, but the data is could be noisy. So if you just memorize, you might actually end up doing poorly. So you have to learn so that you can generalize. Of course, we have to make it more precise, and that will happen in the next sessions. Well, if it is not magic, what is it? It is a bit of math, right? So machine learning, AI all relies on math. You might have already seen I am talking about lines and equations a little bit here and there. If you're not so much, if you're mathematically oriented, there is so much interesting things to learn in machine learning. If you're not so much mathematically oriented, there is still scope for you to learn the essence, right? So at least try to understand, you know, at a high level what is going on, and that is pretty much enough for some applications, right? So to deal with some applications. But if you want to dwell deeper, I think there is so much you know, interesting things that happen when you really put your effort in the math part of it, right? So at this point, I don't want, at least in this workshop, I don't want to say you have to be interested in math. You don't have to be interested in math. That's not the goal of this workshop. Here we are just trying to give a very high level view, and now depending on what your interest is, at what level you want to engage with the subject, you can later decide, you know, what level you want to dig deeper. So that is the what of machine learning. It's a data driven technique used to generalize to unseen data and uses math under the hood, right? So that's one way to put machine learning or AI. Here are some, I'm going to leave you with two questions, and I'm sure this will be addressed in the demo session as well. Let's say we spoke about digit recognition, and let's say these are digits that have been written, you know, using handwritten, right. So, the digit is here, let us say this is the digit, this part is the digit handwritten part, and this is the label, right. So, which means that this is the input and this is the output. When the input is like this, the output is 9. When the input is like this, the output is 7, and so on, right. So, one in green is the output, the label, and the input is the handwritten digit. Now, what might be features that a computer can use? The computers can only deal with the numbers, right. So, numbers meaning actual numbers, right. So, in fact, at the fundamental level, the computer can deal only with zeros and ones, but let us not get into that. The computers need to be given numbers. For example, in the bank manager loan case, age was a number, right, salary was a number, and so on and so forth. These were numbers that were provided as features. Here, what might be features? It's an image, right. So, this is an image of 5, it's an image of 0, it's an image of 4, and so on and so forth. How can I convert this, or how should I think about features that I can input to a computer along with the labels? The labels are clear, the labels are just integers which are in green, but the features right now are like a picture. How can you convert this picture into a meaningful set of numbers that can be given as input to the computer to solve this problem of digit recognition? Guess the features for this problem. This is question number 1 for you to think about. Question number 2 is, here is another example. This is a spam versus non-spam example where you have a bunch of emails. Let's say you have these 4 emails, right. So, first email is, hello, how are you doing? Please reply to this email when you have some time. And then the label is, this is the input. I am not going to call this features, I am just going to call this input, and this is the label. The label is non-spam. The non-spam can be, let's say, 0, the spam is 1, right. So, that is the label, it is just a 0 or 1. But the input right now is just an email, right. So, now if the input is you have won $1 million in lottery or something like that, then the label, corresponding label is spam in your data set, and so on and so forth, right. So, now these are different emails, these are written text. Now, again, a computer can only understand numbers. Now, how can you convert these emails into numbers that can be given as input to a computer? This is what is called as feature engineering from unstructured data, right. So, this is an unstructured data, right. So, there is no, in the bank example, the age was a number, salary was a number, the features were already numbers, we did not have to do anything extra, the numbers were given to us. Here we are given text or images, right. So, now I want you to think about how or what might be reasonable ways to convert either this image in the digit recognition example or the text in an email example into numbers, meaningful numbers that you think will help the computer to map the input to the output. Finally, you have to learn some input output mapping, right. So, the input right now is text and the computers do not know what to do with text, right. So, you have to supply numbers to the computer. How will you convert these inputs into numbers? Or rather, a more precise way to ask is, what are the features for this problem? Think about that, and it would be wonderful to have a discussion about this also with the instructors in the demo session, so that, I mean, there is no single answer to these questions, but we would definitely want you to think about this and come up with some answers and then have a discussion with the instructors, so that you kind of understand the crux of this problem itself, right. So, we will end this session with these 2 questions of guess the features. Next time when we meet, we will discuss things like, how to do these hypotheses, especially let us say in the bank loan payment example, right. So, there we knew what the features were, what the label was, but how can we create some nice hypothesis, or rather how can we develop some algorithms which will help predict for new customer Hari whether Hari should get a loan or not, right. So, that is something that we will start digging deeper into from next time. But right now, today's, just to summarize the session that we have seen so far, most of data science or AI or ML works on this principle of OHLG: observe, hypothesis, learn, generalize, and we saw several examples for that. And now you might observe features directly, and here are 2 examples where you do not observe features directly, but you observe some unstructured data which might be images or text, and I want you to think about how to convert these unstructured data into feature observations, so that you can then do hypothesis learning and generalize. The HLG part of OHLG will come later, but then what you observe should be numbers, and how can you convert these unstructured data into numbers is something for you to think about. I will see you next time with more examples and more algorithms and more interesting stuff. Thank you.